Now we're going to take our understanding of polynomial long division and synthetic substitution, and we're going to use that to substitute for polynomial long division. So sometimes it's called synthetic division instead of synthetic substitution. For this page of notes, what I'm going to recommend to you is to read them very carefully, very thoroughly. Try to read them for understanding and get a good idea of what they're trying to tell you. I'm going to hit some of the higher points right now, and we will continue these conversations in class a little more thoroughly. But basically what we're basically trying to figure out here is we understand that if a remainder of 0, or if an output is 0, we know that that is a 0 of a polynomial function. So we can then take evaluating a polynomial function and kind of relate it to division of a polynomial function. And so that's what the remainder theorem is kind of really all about. Now, a lot of times the remainder theorem seems kind of, just the idea that we're learning a theorem here, it seems kind of confusing, but it's really, really quite simple. And it's basically saying that if we divide something by a factor, divide something, we get a remainder, we get an output. And that remainder is an output. And so we can use synthetic substitution to do that. Now, we're going to call it synthetic division because we're going to be dividing it. Now, one of the things that you need to be aware of is that we are dividing by an expression in the form of x minus c. That is extremely important. You can only do synthetic substitution whenever you're given a linear term like that. If we were looking to divide by an expression, say x squared minus c, we cannot use synthetic in this situation. So the fact that it is a square term means that we have to use polynomial long division to determine a remainder or determine if it's a factor or not. So, however, if we do have a linear expression, in this case x minus c, then we can use synthetic division in place of polynomial long division. And that makes life a whole lot easier. And so you can see in example 3 how dividing by x plus 2 is a form of x minus c. And so we're going to use the negative 2 here. We had to kind of convert to use the negative 2 for our synthetic division in this process. And you can see that we have a final remainder of 0. So if we divide x squared plus 4x plus 4, we divide that by x plus 2, we're going to have an x plus 2 with the remainder of 0, which tells us that x plus 2 is also a factor. That's going to lead us into the factor theorem. So if we go down here and we look at the factor theorem, it basically tells us that if when you divide x minus c, if it's a 0, then it has to be a factor. And then we can factor it and write the polynomial in what's called a depressed state. So read through that a little bit carefully, and then we'll go into writing remainders and factors. And so if we were to divide two things, remember from the previous example that we gave you that we would write this remainder not with an r but with an addition, and so that's what this particular little formula is telling you. Now, what we're asking you to do in sample 3 is use the remainder and factor theorems. It says use synthetic division to determine if it's a factor or not. And so we're going to go ahead and do that now. So if you go ahead and take the time to work part A and B and come back and take a look at the final result. Okay, so what I've done here is I've converted this x plus 2. I know that that needs to be the same thing as x minus c. And so that's the same thing as x minus a negative 2. Well, what we're trying to really determine is this a 0 of the function or not? So I could also make x plus 2 equal to 0, and I'm trying to determine if x equals negative 2 works out, if that becomes a factor or not. And you can see that I've set up the synthetic division here, and I've finished the synthetic division. Now, what happens here is this final value is the remainder. And what that tells me is if it's a remainder of 0, that means x plus 2 is a factor of x to the third minus 3x squared minus 7x plus 6. So negative 2 is a 0 on this polynomial function. Now, here's what you've got to learn how to do. You have to figure out what is the remaining part. So we know that x plus 2 is a function. So if I did this, I said x to the third minus 3x squared minus 7x plus 6. And I asked you to factor this. Well, I now know that x plus 2 is a factor. However, what I need to figure out is what's remaining. Well, that's where the synthetic division comes into play. Since we started off with an x to the third, this first term actually represents an x squared term. So this is 1x squared minus 5x plus 3. And you can see how we use these coefficients to drop down in here and make up the next term. And so this remaining part is x squared minus 5x plus 3. And what you can do is you can always multiply these two parts back together to see if it's factored correctly, and you should get the original polynomial. So in part A, we do have a factor, and we have a remainder of 0. And using the division, we've got the resulting polynomial, that you would multiply to the factor. So let's try that again on part B. Okay, so you can see here again, this was already in an x minus c form, so the c part is 4, which is what we're using for the synthetic division. Again, I'm testing to see if the x minus 4 is a factor of the given polynomial. So I'm doing that with synthetic division. And as you can see here, I have a remainder of negative 6. When you have a remainder like this, what that basically tells me is, since it is not a remainder of 0, like we were hoping that it would be, then x minus 4 is not a factor of this polynomial. Now the resulting division gives us the depressed polynomial here. So this is going to be x squared plus x minus 3, but with a remainder of negative 6 over x minus 4. So this would technically be your depressed polynomial, and we could say that x minus 4 is not a factor. Okay, there's a couple examples of the remainder and factor theorems, and how you can use those later on when we're solving polynomial functions or polynomial equations. You can test different factors through synthetic division.